Our Milky Way galaxy is a vast and awe-inspiring place. It is a swirling collection of billions of stars, gas, and dust. Our Sun, a rather ordinary star, resides within this cosmic structure. We gaze upon the Milky Way from within, seeing its band of stars stretching across the night sky. Despite its familiarity, the Milky Way harbors profound mysteries. Scientists strive to unravel these secrets hidden within our galactic home. These mysteries challenge our understanding of the universe we inhabit. One of the Milky Way's biggest mysteries is dark matter. We cannot see it directly, yet we know it exists through its gravitational effects. Dark matter does not emit, absorb, or reflect light, making it invisible to our telescopes. Scientists infer the presence of dark matter by observing its gravitational influence on visible matter. Stars and gas in the Milky Way move faster than expected based on the visible mass alone. This discrepancy suggests the presence of a hidden mass, the elusive dark matter. Dark matter's gravity plays a crucial role in the Milky Way's structure and evolution. It forms a vast halo that engulfs the entire galaxy, providing the gravitational scaffolding for its formation. Without dark matter, galaxies like our own might not have formed at all. The study of dark matter presents a profound challenge. Identifying its nature would revolutionize our understanding of physics and the cosmos. Another captivating mystery lies in the heart of the Milky Way. Black holes. These objects possess immense gravity from which nothing, not even light, can escape. Black holes form when massive stars collapse at the end of their lives. The Milky Way is thought to harbor millions of black holes lurking throughout its vast expanse. These objects are incredibly dense, warping the fabric of space-time around them. Section 5, supermassive enigma Sagittarius A*. At the very center of the Milky Way lies a supermassive black hole, a giant among its peers. This behemoth, known as Sagittarius A*, has a mass millions of times greater than our Sun. Its gravitational pull is so strong that it influences the orbits of stars and other celestial bodies in its vicinity. Astronomers discovered it by observing the peculiar orbits of stars swirling around an invisible point in space. These stars move at incredible speeds, some reaching up to thousands of kilometers per second, indicating the presence of an immensely powerful gravitational force. Sagittarius A* is a source of intense study. Researchers use a variety of telescopes and instruments to gather data from radio waves to X-rays to understand the complex dynamics at play. The Event Horizon Telescope, a global network of radio observatories, has even captured the first ever image of a black hole's event horizon, providing unprecedented insights. Astronomers are eager to learn more about the role these supermassive black holes play in the formation and evolution of galaxies. They believe that Sagittarius A, scientists hope to unlock the secrets of the universe's most enigmatic objects and their impact on cosmic evolution. Section 6, Uncharted Territories, the Milky Way's unknown. Vast regions of the Milky Way remain shrouded in mystery. Dense clouds of gas and dust obscure our view, making it difficult to observe these areas directly. These hidden corners likely hold valuable clues about the Milky Way's history and evolution. New telescopes and technologies are being developed to peer through this cosmic veil. Scientists anticipate groundbreaking discoveries as they explore these uncharted territories. Section 7, Peering Through the Dust, Exploring the Unknown. Infrared and radio telescopes are particularly useful for studying the Milky Way's hidden regions. These advanced instruments allow astronomers to peer through the dense clouds of cosmic dust and gas that obscure our view in visible light. By capturing wavelengths of light that are invisible to the human eye, these telescopes reveal a hidden universe teeming with activity. From the birth of new stars to the remnants of ancient supernovae, the Milky Way's secrets are slowly being unveiled. These telescopes can penetrate the obscuring dust and gas, revealing the secrets within. The infrared images, in particular, provide a unique glimpse into regions that are otherwise shrouded in mystery. By studying these images, scientists can learn about the processes that govern star formation and the evolution of our galaxy. The ability to see through the dust also helps in mapping the structure of the Milky Way, offering insights into its spiral arms and central bulge. Space-based telescopes like the James Webb Space Telescope offer unprecedented views of the cosmos, unveiling the Milky Way in greater detail than ever before. Positioned far from the interference of Earth's atmosphere, the James Webb can capture incredibly sharp images across a wide range of wavelengths. This allows astronomers to study the galaxy's core, where supermassive black holes reside, and to explore the outer regions where new stars and planetary systems are forming. By studying these hidden regions, astronomers hope to uncover clues about star formation, the life cycle of stars, and the conditions that lead to the creation of planets. The data collected from these observations can help refine our models of how galaxies evolve over time. Understanding star formation is crucial, as it plays a key role in the chemical enrichment of the galaxy and the formation of complex molecules that are the building blocks of life. The distribution of dark matter, which is an elusive and mysterious component of the universe. Dark matter does not emit, absorb, or reflect light, making it invisible to traditional telescopes. However, its presence can be inferred from its gravitational effects on visible matter. By mapping the distribution of dark matter in the Milky Way, scientists hope to gain a better understanding of its role in the formation and evolution of galaxies and the overall structure of our galaxy. The Milky Way is a barred spiral galaxy with a complex structure that includes a central bulge, spiral arms, and a halo of stars and dark matter. By studying its structure in detail, astronomers can learn about the history of our galaxy, including past mergers with other galaxies and the processes that have shaped its current form. This knowledge not only enhances our understanding of the Milky Way, but also provides insights into the nature of galaxies throughout the universe. Section 8. The Quest for Life Beyond Earth. The mysteries of the Milky Way extend beyond understanding its physical properties. This vast galaxy, with its billions of stars and countless planets, holds secrets that have intrigued humanity for centuries. From the ancient astronomers who first charted the stars to modern scientists using advanced telescopes, the quest to understand our place in the cosmos has been relentless. One of humanity's most profound questions is whether life exists elsewhere in our galaxy. This question has driven scientific inquiry and inspired countless works of science fictions. The idea that we might not be alone in the universe is both thrilling and humbling. It challenges our understanding of biology, chemistry, and the very nature of life itself. The sheer number of stars and planets in the Milky Way suggests that life may have arisen on other worlds. With over 100 billion stars in our galaxy alone, and many of them hosting planets in the habitable zone, the potential for life is staggering. Scientists have discovered thousands of exoplanets, some of which show promising signs of being able to support life. The search for extraterrestrial life is a driving force behind many astronomical endeavors. Missions like the Kepler Space Telescope and the upcoming James Webb Space Telescope are designed to find and study these distant worlds. By analyzing the light from these planets, scientists can determine their composition, atmosphere, and potential for habitability. Discovering even the simplest forms of life beyond Earth would have profound implications for our understanding of life in the universe. It would suggest that life is not unique to our planet and could be a common occurrence throughout the cosmos. This discovery would not only answer one of humanity's oldest questions, but also open up new fields of scientific research and exploration. The quest for life beyond Earth continues to push the boundaries of our knowledge and imagination. Section 9. Unraveling the Milky Way, a cosmic endeavor. The Milky Way's mysteries beckon us to explore the universe's wonders. Unraveling these cosmic secrets is a testament to human curiosity and our desire to comprehend the vastness that surrounds us. Each new discovery brings us closer to understanding our place in the cosmos. The Milky Way, our galactic home, serves as a constant reminder of the universe's grandeur and the countless mysteries that still await our exploration.